The topic of this video is determining the inverse of a function, and very specifically the subtopic, verifying two functions really are inverses of each other. Let's look at a problem. A student solved a problem. He was given f of x equals 1/2 x subtract 2, and he determined that f inverse of x equals 2x plus 2. Is he correct? All right, well, to know if he's correct or not, we need to take the function f and the function f inverse and compose them in both directions and show that we get x both times, or maybe that we don't. All right, so here's what we're going to do. This is a statement that must be true in order to say that the student is correct. We're going to work on just the left side, which means we're going to focus our attention on the part here in the red box. So I'm going to take this equals x, and I'm just going to move it down to the bottom so that it's out of our way. All right, now let's find out what this is equal to. Well, we've got the composition of functions where the innermost piece is a variable. That means that we work from the outside in. The outside function is f. So our next line of algebra is going to use function f, and specifically the right side. But everywhere we see x, we're going to put f inverse of x instead. So we get 1/2 times f inverse of x subtract 2. We replace the x with f inverse of x. All right, now we're going to substitute. F inverse of x is equal to 2x plus 2. So 2x plus 2. Next, distribute the half. Multiplying by a half is the same as dividing by 2. So 2x divided by 2 would be x. 2 divided by 2 would be 1. So we get x plus 1 minus 2, which is x minus 1. And that does not equal x. Therefore, we can stop. We don't need to go any further. In order for the student to be right, both compositions of functions have to give the result x. If even one of them does not give x, then immediately we can say the function f and what we thought was its inverse are actually not inverses of each other.